Hello everyone. Hi, this is Mahesh. Welcome to this YouTube channel. In the previous two lectures, I have explained about what is meant by impulse turbine with the help of diagram. Neatly I have explained, and what is meant by reaction turbine, what is the working principle of reaction turbine with the help of the neat diagram, and I have drawn the PV, that is pressure and velocity diagram also. In today's class, I would like to explain the differences between the impulse turbine and the reaction turbine. Okay, what are the differences there in the impulse and reaction turbine? This is impulse turbine working diagram, and this is the reaction turbine working diagram. Why I place up nearby means with the help of this diagram, if I explain means that will be very clear to you. That's why I am taking two diagrams of the reaction turbine and impulse turbine. I am explaining. See, in the impulse turbine, what will happen means impulse turbine consists of a set of nozzles and followed by the moving blades. Here the set of the nozzles will be placed and throughout the turbine and the moving blades here. When the steam from the boiler comes and enters into the steam nozzles, you know what is the function of the nozzle? Nozzle will increases the kinetic energy and decreases the pressure. Whatever the amount of pressure that is decreasing, that pressure is utilized to increase the velocity of the steam, and this high velocity when touching the blades, from that blades the expansion will take place in the blades, and because of that expansion the blades are rotating. See, in the reaction turbine it consists of a set of fixed blades followed by the moving blades. Here a set of nozzles followed by the moving blades, but here fixed blades followed by the moving blades. Here you have to remember one thing, that the nozzles are absent in the reaction turbine, but these fixed blades will serve the function of nozzles. However, the nozzles are performing in this impulse turbine, the same work will be done by the fixed blades in the reaction turbine. This is the first one. In that it consists of set of nozzles and followed by the moving blades. In the reaction turbine it consists of set of fixed blades followed by the moving blades. Second point. Here, because of the impulse force only, the rotation of the blades are taking place. Okay, what is meant by impulse? I have explained in the previous class. See here, once again I am explaining impulse. Now the steam is coming from the nozzle. The steam is having some mass m and it is having some initial velocity u. Assume when this jet of steam is coming and touching the blades, then what will happen here? Velocity will changes. That means when touching the blades, the velocity will be changes. The blade also changes its direction. Here initial velocity is there mu and final velocity is there mv. That is, you know the formula of momentum. Momentum means what? Momentum is equal to, it is a product of mass into velocity. Now here change in velocity means this is final velocity minus initial velocity, that is change in momentum. The change in momentum is taking place here in given particular time interval of time. Therefore, the change in momentum per given time is called as a force. This force is called as a impulse force. Because of this impulse force, what is the force produced by this jet of steam as an impulse? Because of the impulse force only, the turbine is going to rotate in the impulse turbine. That's why the turbine named as a impulse turbine. In reaction turbine, what will happen? Here in fixed blade expansion is taking place. That means velocity increases and pressure decreases. Again, when the steam is entering into the moving blade, in this moving blade also the expansion of the steam takes place. Here two times expansion is taking place in this one. Because of this, here also pressure decreases and velocity increases. Therefore, because of this one, here velocity decreases. Because of this two times expansion, the reaction will be produced in the moving blades. Because of the reaction produced in the moving blades, the turbine starts rotating. That's why this is called as a reaction turbine. Here, because of the impulsive force produced in the turbine start rotates. Here, because of the reaction force produced by the moving blades, the turbine starts rotate. This is the second point. Now, third point. See, I have drawn this pressure and velocity diagram. Here, in the boiler, the pressure when the steam is entering into the nozzle, you know its velocity increases. This green line will indicate the velocity and this red line will indicate the pressure. And velocity increases and pressure will be decreases in case of the nozzle. Coming to the moving blades, what will happen here? In moving blades, the velocity is decreasing. Here the pressure also decreases in case of impulse turbine. Pressure also constant in case of turbine. Here see the pressure is constant. That means in the impulse turbine, the pressure will be constant in the moving blade. This is the third point. And coming to the reaction turbine, here this is serves as a nozzle. You know, in the nozzle what will happen? Velocity increases and pressure decreases. Therefore here pressure decreasing and velocity increases. But coming to the moving blade, here what will happen? Again the velocity decreases and the pressure also decreases. But here pressure remains constant, here pressure is decreases. That is the third point. Next one is, here steam strike the blades because of only kinetic energy. Okay, here the steam is striking the blades only because of the kinetic energy, but here the steam striking the moving blades with both potential energy, potential energy and the kinetic energy. Here both pressure energy and the kinetic energy. Because our here pressure is somewhat only completely not decreasing, only partial pressure is decreasing, therefore it is having some pressure energy, and the kinetic energy, you know, in the nozzle the kinetic energy will be there. Because of the pressure energy and kinetic energy, the reaction turbine works. Here the steam strike the blades only with the kinetic energy. Here, and the fifth point in this, the blades are symmetric in the impulse turbine. Here the blades are symmetric, but the reaction turbine the blades are not symmetric. Symmetric means what? That is, the image should be same in the, when you see in the mirror, the image should be same. Or when you fold that, it has to cut through either x-axis or y-axis. If you fold that one, the image should be same. That is called as a symmetric. For example, take this one. Here if I cut along the x-axis, if I fold this like this, then what will happen? On this, the folded should be placed like this. Both the shapes or size should be same. That is called as a symmetric. If you cut about the y-axis, if you fold in this way, and the shape has to be same when you fold right side. This is called as a symmetric. Next one is, the efficiency will be low in the impulse turbine and the efficiency will be high for the reaction turbine. Here the impulse turbine develops the smaller power and the reaction turbine develops the larger power. It occupies the less space for the same amount of production of power, but it occupies the more space to produce the same amount of power. This is the difference between impulse turbine and the reaction turbine. And last one, this is used for smaller power develop and this is used for large power develop, and these are the differences between impulse turbine and the reaction turbine. Thank you.